Okay, so let's look at these. So one of the first things we looked at that you guys had looked at from pre-calculus was to look at limits from a graph. And so, get a pen. Okay, so we're going to look at 2. So at 2, remember you don't really think about what the output is at 2. You think about what you would expect it to. So we would expect the output to be here. So this is the limit. At 2, the limit's 3. And then we want to look at one-sided limits. So let's think about it 0. If we're coming from the plus side, that means we're coming from the right. We would expect the output would be 1. But if we're coming from this direction, we would expect the output to be 3. And since those two outputs don't match each other, those two expectations don't match, we say that the limit does not exist. Okay, so let's look at the next one. Let's do blue. Oh, let's do the blue. Let's do orange. Okay, so we need the function to be continuous. So the function is not continuous here. That's a jump discontinuity. That has a point of discontinuity. It's a removable discontinuity because you filled that point in, it would be continuous. So those points don't count. So we're looking for all the other points where the function's not differentiable. And the function is not differentiable at x equals 6 because from this direction, the derivative, since it's a line, you could say it's like the slope. So from this direction, you expect the derivative to be, is that 1/2? Or from this direction, you expect the derivative to be -1. And since those two expectations don't match, the derivative doesn't exist there. Okay? And then we talked about the 3 big theorems. The IVT says that a continuous function takes on every intermediate value in between two outputs. So if you've got this point here and this point here, somewhere on this interval, you've got an output everywhere in between these. Okay. The extreme value says that on that closed interval, you have a highest value and a lowest value. But for the mean value theorem, that says that the AROC is equal to the derivative at some point. And that you have to have a differentiable function. The function's rate of change has to change smoothly. Okay, let's look at the last group. I'll go back and grab my blue pen. Okay. So I'm assuming at least one time they're going to ask you about the chain rule. And I kind of liked this question because you can't just type this in your calculator because you have to use the graph. And so let's find h prime of x would be f prime of, keep the input, but then you need the chain rule. So you times it by 2x minus 2. So that way, if we're going to find h prime of 3, it would be f prime of, what would that be if we put in 3? 9 minus 6 plus 1. And then if we put in 3, it would be 6 minus 2. So this is 4, and this is 4. Okay, now if we look at the graph, if we go up to where 4 is, since we're looking for f prime, it's not the output value, it's the slope value there, and that's -1 times 4. So its answer is -4. Okay, now let's look at the last one. You're like, oh, that's the last thing we learned, Miss Brady. It's the thing we learned when we started to miss each other and we were working at home. Your guess is this is L'Hopital, so let's just check it out. If you put in 3 and tried to evaluate the input, you will get h of 3 minus 1 over sine of 3 pi. This is 3 pi's 1, 2, 3 here, so this is 0. And h of 3 would be f of 4 And from my graph, f of 4 is 1, so this is 1 minus 1, which is 0. It's like, oh, this is L'Hopital's rule. Okay, so this is the same as the limit as x approaches 3, and you take the derivative. So it's h prime of x over cosine of pi of x. Don't forget baby chain rule times pi. And now your hope is now you can evaluate this and get a number. So we actually found h prime of 3. So it's h prime of 3 over cosine of 3 pi times pi. We found h prime of 3, that was negative 4. And cosine at 3 pi is negative 1 times pi. So I think this is 4 over pi.